ส่วนเป็นครั้งแรกอย่างเป็นทางการนะครับก็ขอเรียนเชิญนะฮะกล่าวทักทายนะครับพี่เล็กเรินใจนะครับดรรินใจชาครพิพัฒน์ครับพี่เล็กครับท่านผู้ช่วยผู้จัดการกลุ่มงานพัฒนาธุรกิจและผลิตภัณฑ์ตลาดหลักทรัพย์แห่งประเทศไทยครับวันนี้ยังไม่เอาใหม่ดีครับ
ก็กับสวัสดีนะคะท่านผู้บริหารบริษัทหลักทรัพย์นะคะแล้วก็ท่านผู้เกียรติท่านนะคะก็ขอในนามของบริษัทตลาดสัญญาณซื้อขายมุ่งหน้านะคะก็ขอต้อนรับทุกท่านนะคะเข้าสู่งาน Corporate Networking นะคะซึ่งจริงๆแล้วตลาดพันธุ์จะเป็นประจำนะคะปีแต่สำหรับตัวฉันเราก็ไม่ได้มาร่วมงานหลายปีวันนี้ก็เลยมีส่วนยินดีอย่างยิ่งนะคะที่ได้มีโอกาสมาร่วมงานครั้งหนึ่งนะคะแล้วก็หวังว่าทุกท่านก็คงมีความรู้สึกอย่างเดียวกันนะคะเพราะงานนี้ก็เป็นงานที่เรียกว่าเรามาเรียกว่าหาความรู้นะคะแล้วก็คุยกันแลกเปลี่ยนความคิดกันนะคะแล้วก็มีโอกาสได้แชร์ประสบการณ์ดีๆนะคะจากวิทยากรนะคะซึ่งในวันนี้เนี่ยเราก็ได้วิทยากรที่เรียกว่ามีประสบการณ์เรื่อง high frequency trading นะคะ high frequency trading แล้วก็เรื่อง option เรื่อง strategy ต่างๆนะคะเป็น market maker ก็มาแชร์ประสบการณ์ให้เราฟังนะคะซึ่งนั้นก็หวังว่าเราก็คงจะได้รับความรู้อย่างยิ่งนะคะจากท่านวิทยากรในวันนี้นะคะแต่ก่อนอื่นที่เราจะไปถึงงานนั้นนี่ขออนุญาตนะคะอันนี้เป็นทีมงานสั่งมานะคะว่าวันนี้ให้เราแนะนำนะคะโครงการ Top Trading Champion นะคะ2014นะคะอยากเรียนว่าท่านใดที่ยังไม่ได้ลงทะเบียนนะคะเข้าโครงการก็รีบๆนะคะเพราะว่าจริงๆโครงการเรามี2เดือนเท่านั้นเดือนละ6รางวัลนะคะซึ่งเราให้รางวัลกับเทรดเดอร์นะคะแบ่งเป็น2ประเภทนะคะประเภทแรกคือ most active นะคะซึ่งเป็นการให้รางวัลสำหรับคะแนนการซื้อขายสูงสุดนะคะอีกประเภทหนึ่งก็คือ most growth นะคะก็คือจะมีอัตราเติบโตนะคะของคะแนนการซื้อขายสูงสุดถ้าถามว่าคะแนนนั้นมาจากไหนนะคะคะแนนมาจากการซื้อขายนะคะ3ระดับนะคะก็คือ mini sensitivity features นะคะ3คะแนนนะคะโต50 บาท3คะแนนแล้วก็โต10 บาท1คะแนนนะคะอย่าลืมนะคะว่าถ้าท่านยังไม่ได้มีรายละเอียดนี้สามารถติดต่อได้จากพนักงานเลยนะคะของ P-Tech ทุกท่านนะคะแล้วก็อย่าลืมมาร่วมกันเข้าโครงการนี้นะคะส่วนในวันนี้นะคะดิฉันก็ต้องขอบคุณนะคะ P-Tech นะคะที่เป็นเรียกว่าเป็นผู้ให้ความช่วยเหลือนะคะที่เราได้สามารถมีวิทยากรนะคะในวันนี้นะคะแล้วก็ขอให้ทุกท่านนะคะมีความสุขกับงานสัมมนาในวันนี้นะคะแล้วสุดท้ายนี้นะคะ last but not least I would like to thank Mr. Rajib and Chris นะคะ for your sharing today. We have launched sensitivity options for quite a while and we wish that the sensitivity option will be one of the most successful product as it happens in the other country. I think that today your sharing of knowledge will not only be beneficial to our work here, but I also think that it will be a stepping stone for our community to start thinking about how to trade options, how to make profit, and how to take that opportunity. So, thank you very much.
Please help me give a warm welcome to our speaker, Mr. Rajib Ranjan and Mr. Nitesh Khandelwal จาก Quantum ครับ
So, thank you very much for your appearance today and thank you for organizing this workshop. So without taking much time, let's start. I'll just set the ball rolling for the workshop. So today's workshop, cool, thanks. So in today's workshop, we'll be primarily trying to see what is algorithmic trading, why is it needed, and why you should know about it. Right. So that's there, and we'll also try to take a practical demonstration on globally leading algorithmic trading platforms, exchange. So we'll see how strategies can run over there, and how can we do automation on that. That's part of that, and we'll also cover a bit on the technology side. So that's actually the real game changer for algorithmic trading, because you all have been told have been into trading already, so you know probably about trading a lot. but it's the inclusion of technology which makes the algorithmic trading so different from what we have the trading that we used to know conventionally. Okay, so we'll keep this we'll try to keep this session mostly interactive. Any questions, please feel free to interrupt us in between, so you don't need to wait for the Q&A session. The whole session can be a Q&A session, so that should be all right. And yeah, and if there are any queries, so let's start with the query instead. So what exactly just comes to your mind when you say algorithmic trading, and what are the things that you would actually like to know about it in today's session? Anyone? It's a small room, so I think you can just shout and you could be audible to all. Something? No? No? Okay. Alright, then I'll go with my agenda. So, okay, so let's start with the point of what do you do if you have a profitable strategy? So what exactly would you like to do? As in, obviously you would like to make money, but to make money, what you will be doing? So these are the few things that you would like to do. So first is you would not like to miss on the opportunity. Do it as much as possible, right? Do it as frequently as possible. So that's one thing that what we call don't miss any opportunity, do it as frequently. Then second would be scale it up. So you would like to, like, if you have some winning strategy and you have been able to apply that for say high bar denominated gold, okay? So if you have a silver trading there as well, then you would probably like to implement it on silver as well, right? Now forget about commodity, that's too smallest, so very few scripts. But say if you want to trading a stock, so if you have a stock and you have a winning strategy, so you would probably like to run it on maybe 10 stocks, 100 stocks, 1000 stocks if possible, right? So you would like to basically scale up your trading strategies. And third would be don't let your emotions affect. So that's the biggest, I think, the challenge that any trader faces on when to cut losses or when to cut profits. So it's either the greed or the fear which takes over, right? As most of you must have witnessed at some point of your trading career, that emotions do affect your trading results. So now, to do that, how does automation help? So for the first thing, if you're not doing it yourself, but if you are deploying computers or the machines for the task, so they are always at their seats, they don't need to eat or drink, they don't need any breaks, right? So it's there, they are always there at work, and they can respond. So basically when, if I'm seeing you and say if I'm driving a car, so a typical response time for when you're driving a car and to react to something which is happening on the road is typically 50 to 150 milliseconds, right? So you take time. So that's like when you are on your toes when you're driving a car, when you're driving. But when you're trading, you might not be on your toes all the time. But even if you are, you will take probably a second before you can react to anything that is happening on the screen. So what computers can do that in microseconds, so which is like 1 millionth times lesser than what the time that you will probably take. Regarding scaling it up, you can probably monitor 10 stocks, 15 stocks. If you are like Superman, maybe 50 stocks you might be able to monitor, but a machine can actually track thousands of stocks, and that's just limited by the number of stocks that are listed on the exchange. Even if it is 1 million, I don't think machines would mind, right? So that ways you can actually scale up as per your need, as per your requirements, without thinking about the scalability issues. And third is emotions. Obviously, machine has no emotions, so that's also a good thing, and we will later on see that that's also a bad thing at times. But yeah, for now, it's definitely a pro when you look at it from the greed and fear perspective. Alright. So, bottom line is that if you are trading, especially you are doing your trading scientifically in a more scientific manner, most likely you will be deploying a lot of statistical, a lot of quantitative tools. And for that, what you will be effectively doing is that you will be doing probability, you will be checking the probability of moves, up moves, down moves, whatever moves are happening in the market. And you would like to compute the probability and do all sort of computations, calculations, and the various methodical calculations that you will be doing. So that forms the core of the trading, and that can only be probably much better than by the computers and supercomputers and things of that sort. So yeah, so that's the thing. So obviously, given that the machines have, it's a matter of fact now, which was a question maybe a decade or 2 decades back, but it's a fact that the machines have taken over the human beings, especially in the trading domain, and that's true globally, not just in the select few markets, but all the leading markets, and more so in even in almost all the emerging markets as well. So it's basically the body of a human, but the head of a machine, which is at work now. So this transition, how it has happened over the years, is like it all started in 1971 when the actually 1969 unofficially, as in terms of the exchange, it was not on exchange but on Instinet, but there were orders which were sent using algorithms in way back in 1968, 1969. So till that time, it was all bits, and in most of the markets, till even till 90s, it was bits, right? The trading bits, the old timers might know that all the trading used to happen with the notations or buy, sell, whatever you want to do. So you would give your gestures, and there would be specialists who will be sitting over there. So or on the top, and they will execute your orders, right? So that was in like 1970s, 80s, and some markets even till 90s. But this was changed to the computers, in which the electronic trading was rolled out for most of the markets. So you have electronic trading where you can sit at your home or your office, but any location, and you can trade through the computers. That's electronic trading. And then it moved to more computers, right? So earlier it was like one terminal which you were monitoring. Then it moved on to like 10, 20 monitors that a trader typically monitors these days, right? So this is obviously furthermore more terminals. But yeah. So this overall growth that you see, so we have taken an example of, say, the developed markets here. So US and Europe. So US already you have almost 70% of the volumes which are traded algorithmically. So which is traded using automation. And this is in terms of the overall turnover. So that's a big number. And you have seen a gradual but explosive growth. And this for US, this is for Europe, and both have been like, Europe also have almost 40% of the volumes are through algorithms. If you look at the number of contracts, the number would be even higher. And these numbers are till 2011. The recent studies, they suggest that in US, especially in the equities, on NYSE, you have more than 80 to 84% of the volumes. They are through algo, right? So that's why we said that they have already taken over the humans in terms of in terms of trading, right? And this is the growth that you see, that we have seen. This is for options. So it was like since 1999 till estimated numbers for 2014. So the growth, the overall volumes, they have been aided by like the trading that has happened, as in the high frequency and the algorithmic trading, which has come to the fore. So that has helped the volume rise in a very dramatic fashion. So this is like the CAGR of almost 13% since in last 15 years, which is quite good. And same for FX volumes. In FX, you will see that you might be witnessing over here in Thailand as well, that earlier the corporations, other financial institutions and banks, so banks were like 70% just 2 decades back, right? And corporates and other financial institutions were like very marginal. it has increased to like the volumes have exploded, obviously, but the demographics or rather the structure have changed. So now you have banks, which is like less than 40%. The other financial institution, this has taken a big jump. And this is primarily because of all your hedge funds or mutual funds or your prop trading firms as well as in who classify as institutions. So all those firms have actually expanded heavily and in the overall FX domain as well. So FX is no more just a tool for lending or foreign lendings, all those things, but for massively for trading for profits as well. And in the equities, so this is more detailed one. So what you can see here is the interesting part is that this red line is average shares per trade. So the average shares per trade, this was like somewhere between over here, which has gone down like almost 10 times. It has gone down. So the ticket size or the average trade size that have reduced heavily. Okay. So that the primary reason is obviously this is again a massive effect of algorithmic trading, where the orders which used to be sent for like huge big size orders, they have been broken down into like very tiny small orders which can be sent over like 100 orders in a second or 1,000 orders in a second. And so instead of sending like a share for order for 5,000 shares in 1 second, now you can actually send 100 orders for like 50 size of 50 shares each in 1 second, right? So that's there. And over here, if you see the high frequency, also, okay, so this one is average shares per day. So that has increased, but the average trades per day, that has been phenomenal. So that's why your average shares per trade has reduced, but your average average trades per day, that has increased heavily. So that's there. And again, the most of the asset classes which has been traded by HFT firms across all markets globally. So you'll see that almost more than 80% of the firms, they do trade using algorithms now in the stocks and shares. Futures and options, the futures is like almost 70%, options is close to 60%. It's only the foreign exchange which you see is still lagging behind at like 25%, but that's probably just a matter of time, because the banks, most of the the conventional banks or the not the old age banks, they are still it's still the phone market which is more prevalent rather than the electronic market. So yeah, so that's there. But now the effect of algo trading, the other side. So unfortunately, the computers does not think, as they do not have emotions, as we saw on the first slide. So the problem is that if computers just do what you ask them to do, so if you do not think it out properly, so it can wreak havoc. And when we move to the risk management part of the session today, you'll see some very interesting but heartbreaking stories of how the risk management was taken on a ride by some of the algo firms, or how it created havoc in the market. Okay, so we have just taken one example, or over here, which is like last year, I think 22nd April 2013. So there was this trade in Google. This whole thing has happened in like 3/4 of a second, so like 750 millisecond. So the prices went up from like they were about 800 till 775 for a stock like Google. That's a big jump. Okay, so like 2.5-3% in a split second. It's a big jump, and it was basically some algo going berserk and the other algos chasing it up. But the good part is that this does not last. Earlier, when it used to happen, it will make a permanent impact on the market, which does not happen anymore, because there are so many players, there are so many algos which are reacting like instantly. So the market has become much more efficient because of algo trading. But some rogue players might just break all the market, even for a split second. So yeah, so that's there. So overall, if you look at the pros and cons, you have the trading algorithmically. It generates definitely generates more profits because there is no downtime. It's there right on its desk all the time, every time, without missing anything. Right? No emotions, good and bad, but mostly good. They react to the situation faster, as we saw that like within microsecond, and with even better technologies, it's like in single-digit microseconds, you can react to the situation. Higher scalability, obviously. 10 stocks is not a cap anymore. Not even 50 stocks is not a cap. It's like hundreds or thousands of stocks that you can trade on a single machine, right, by a single trader. And accurate and faster calculation. So like those of you who are into like high-end quantitative trading method, who deploy high-end quantitative trading methodologies, you will see that obviously when you're using R or MATLAB or various tools using various APIs. It's like it's the number of calculations that can be done. It's mind-boggling. So that's the profitable part, the pros. But the cons is that all these things that is making the overall trading environment much more complicated, because obviously you have the technology which has seeped in. So the traditional trading system is quite simple. We'll be going it in further details in the technology part, but this one is like a simple application which you open on your desktop. The server where the market data used to come, nothing else, nothing much apart from that. Maybe some data for your data analysis, and some order routing manager which was there, say some tool that you guys might have for sending the orders to the exchange from your front end terminal, right? So that connects to the exchange, or this connects to the data vendor. That's it. That's about it. Nothing else. But now it has got bit more intensified. Your front end has moved over here, and your strategy UI settings and the strategy management, the PNL, everything has to be automated, right? So a lot of boxes which has come in on this center part, and this part has been reduced more to the more to your visual aid than anything else. So decisions are not being taken over here anymore, which was the case till this time. So this is where all the operations, all the decisions were being taken by the trader. That's not the case. All the decisions are being taken over here now in the complex event processing engine, right? So all the calculations, everything is done in the server itself. Obviously, you program it, but it runs when in the runtime. It's just a server, and it is no more like single exchange that you can focus on at a time. You can focus on like 20 exchanges, 100 exchanges. There are firms who trade like who provide access to like hundreds of exchanges, hundreds of trading destinations through the single platforms. So that ways the overall uh, the overall architecture has changed heavily, and that has increased the likelihood of errors or something going wrong anywhere, anytime. The likelihood has increased, but that's the thing, that you have to do it perfectly. You cannot do a all right kind of job anymore. So that's why it can be riskier, but you can obviously, uh, if you contain the risk, then the profitability is huge. But the idea is that you must contain the risk. Okay, so let's see about enough of, I think, bashing of our own domain, but let's look at some of the benefits of high frequency trading. So we have tried to break down the benefits into three parts. So one is the benefits to the trader, second is benefits to the markets, so, or as we in our industry we call it the social service that the algorithmic traders do, and the spillover benefits to the other industries, to other industries or the related industries.
Okay, so obviously starting with you, that is the traders, we have already seen that it improves the scalability, increases system time, faster response to events, trade more opportunities, all the same things that we have. And the interesting part is the last point, the better risk and portfolio management. So far we were seeing that the risk has increased, right? It also what has also happened is that risk management has also improved thanks to the technology. So now the way the risks were managed earlier on, that has totally been taken over by like different algorithms which make sure that every order which you're releasing in the market, that is being checked on, that is being before it reaches the exchange, it can go through the several layer of checks and risk checks, and within a matter of like micro to milliseconds. So that ways it has helped in much better risk management too, for the benefit to market. So the social service. So that's it has improved market liquidity, as we have already seen through in the earlier slides. The data, the volumes have increased, the average trade size has gone down, the stability of the market has also increased. So like when we saw that in the example of Google, all it took was 3/4 of a second to drag the market down, but it did not take more than a second to get it back to the same level, right? So, yep, your mic.
I'd like to give one more example. So basically, the fact that everyone bashes high frequency trading, but the benefits are earlier the market bid spread used to be quite high. So if there was a trade on the buy quote followed by a trade on the sell quote, so if there was a trade on the buy quote, so the bid was at say 90, the ask would have been at 95, the best ask would have been at 95, and so on. And so if there is a trade at the bid followed by a trade at the ask, the volatility in the underlying prices have actually gone up. And then if you buy and then if you have to sell immediately, you have to incur a huge loss. Now, because of high frequency, the fact that market makers could quote much tighter because they have the confidence that their systems could respond faster. A human being cannot respond fast, but an automated trading system can respond fast. So therefore, it gives them the confidence to quote much tighter. So if they feel that the fair value is 93, now they will quote at 93.2 and then probably 92.8. The moment there is a change in the fair value, they would just respond straight away. So what it means is that the volatility in the price changes of the underlying has gone down drastically, because if there is a trade in the buy side followed by a trade in the ask side, the difference between the two prices is quite less. And then if you mistakenly do a trade on the buy side and then you have to get out of your trade, so you don't incur a huge loss. Sorry.
And the another benefit that has seeped out of exactly what Rajib mentioned is the reduced cost of trading. So when we say cost of trading, we are not really referring to your exchange charges or the government taxes, all those things, but the bid ask that you used to pay in the exchange for trading stocks or anything, any asset class. That bid ask has reduced drastically, just like as Rajiv mentioned just now. So there was this study which estimated that average retail trader, like the people who, I'm not saying about retail, but there's a lot of bashing which is done for algorithmic trading globally. But it says that it has been quite the benefits have been quite democratic, that even the average retail trader who has nothing to do with algorithmic trading as such, he also saves like close to like $500 every year on just on the tightening bid-ask spread. That's it. Other benefits are there, but just by the tightened bid-ask spread, average retail trader who is not really that active, who does not do that much volume, even he is saving on an average $500 a year. So that's there, and then obviously the same thing has resulted in reduced volatility of markets. So one reason is what Rajib just mentioned, so that bid-ask spread, that is not that wide, so the jumps are not that huge, and also since the reaction time is much faster these days. Okay, so if there is some news and something wrong happens, like we saw again in the example of Google, it again comes up within a moment. so it does not last. So therefore the more stability, and obviously the market efficiency has increased a lot. The primary reason, or rather a good example that I can give you is you have stocks and futures both listed on like stocks on SET and futures on TFX, right? So a lot of people might be doing, let's say, cash future arbitrage. So the cash has its own market, future has its own market. There would be possibility that that the cash moves in a different manner and future moves in a different manner, even though future is supposed to expire on the cash value at the end of expiry. So that phase there might be a lot of arbitrage, which, and arbitrage is nothing, to be honest, but result of market inefficiency, right? So with a lot of players which are involved into uh, taking care of arbitrage and these kind of strategy, the overall efficiency of the market has improved. So, which is probably not so good for some traders who are actually into that arbitrage business, but it's good overall for the market, because the retail guy or the guys who are looking for a better investment or better prices, they're getting a more transparent and more efficient field. Okay, and it has also reduced the dependency on brokers. So I can tell you that there were some markets where what used to happen was that you will have the broker, all the big institutions, the fund managers and all, they will send orders to their broker, and they have big orders, right? So there's some big fund manager or some big mutual fund guy, he's sending an order to buy some stock, and obviously since it was done in a manual manner, so it used to take like 5 hours to like almost a day at times to execute that order, and that time happened to be good enough for the trader who was getting that order, or the dealer who was getting that order, to maybe front run the position or actually skew the market in his own favor, right? So those kind of things used to happen a lot, which has now gone for a toss, because now brokers can actually give direct DMA. So exchange, you can connect to the exchange directly. So there is no dependency like this on the broker. So you still go through the broker, but it's a direct market access. So you're reaching the exchange directly. So that all that shady business is gone in most of the exchanges now, or most of the markets. And it has also, of course, improved the infrastructure at the exchanges end. So to be more competitive, exchanges to give the access to the high frequency traders, you need to have that kind of technology, for which obviously exchanges are also rewarded in terms of more volumes and more incentives, but obviously they have to improve their infrastructure to actually accommodate that, right? So that has improved, and as a result, the response time of the exchanges that have also improved drastically. So there were exchanges which used to take like 500 milliseconds, 200 milliseconds to just give the acknowledgement for the order, and now they do it in like less than a millisecond and even faster, some of them. So that phase, it has improved the risk management as well for the traders or for the market makers who were making the markets for the overall market. So that's there, and then the spillover benefits. So this is like, these are the things which have happened and are benefiting all the industries, various industries, be it automobile or be it your even e-retailers, so like Amazons of the world and all. So they are also getting benefited from the complex event processing and the multitask management, multi-thread management that has been developed for by the algorithmic traders, because algorithmic trading is like, you see the results instantly, right? So if you do it good, you make money. So obviously a lot of investment in technology goes into this. So globally, you will see that the most investments in technology are done, number one, in defense for altogether different reasons, and number two, in the financial markets. Okay, so obviously one is for survival and other is for making money, right? So that ways, all these things like CEP processing or your artificial intelligence systems, ability to process huge information flow. So this is something which has helped all these guys like big technology firms, like even the search engines like Google or your e-retailers like Amazon's. All these guys have been able to use these things. They have been able to create their abilities, which is in the related domain. Real-time missions for most critical stable systems. This has particularly improved the in the medical sciences. It has contributed a lot. So especially for the life-threatening monitoring, what do you say that? Symptom monitoring for your body. So that's there, and obviously the statistical systems to process and analyze monstrous amounts of data. So this is like all your satellites which are sending data. So this is something which helps that. And accelerated hardware and hardware programming. So this is like to improve your performance. So like right now I'm using this presentation. So when I click next, it takes some time. Previous, it takes some time. So because it is going through, first obviously this is a laser, that's one thing. Then again, there's an operating system on my computer. There is a presentation PowerPoint software that is running. So all these things actually take some time. So if you want to make things even faster, so what people do is that they just eradicate the whole software and they just program everything on the chip itself. So that's what it's like your accelerated hardware or the hardware programming is. All right, so let's move to the technology side. I think we'll cover that a bit on what is the system architecture, how does it look like. So Rajib will take that.
So welcome everyone to the workshop on algorithmic and automated trading. So it's a privilege for us to interact with so many traders from the Thai market. So the second session is on the technology aspect of automated trading. So automated trading is so very centric, so very dependent on technology that the trader actually has to understand the technology behind the system. So if you see that something is going wrong, you need to be able to understand what exactly is going wrong. If you see that your system is not making as much profits as it used to make, either it could be because of a change in the strategy model, or it could be because technologically there are changes that are happening. People are becoming faster than you, and then you are responding slower, or something, or your system is not up to speed anymore. Okay, so basically for traditionally, a trader would be someone who understands quant models, and a technology guy would be understanding technology. But with the advent of algorithmic trading, this has changed. A trader now needs to understand not just the quant models, but also needs to understand the technology within the automated trading system. If you understand the technology within the automated trading system, you know where your profits are. If you're starting to make losses, you know what could possibly be wrong in your system. So the structure of this presentation is, first we are going to look at the architecture of a traditional trading system. When we look at that, we will be able to appreciate how things have evolved, the changes that have happened, the current day architecture of an automated trading system, what are the enhancements that have happened. Yeah, that is how we will do it. So a traditional trading system, what would it contain? It would contain a system to read data from the market. You would then process the data, you would analyze the data, you would store the data, you would analyze the data, and then you would input that trading, and then based on your analysis, you would input a trading decision into the system and then say buy or sell in the market. Now the system should then be able to send the orders to the exchange based on that signal. So to depict it graphically, this is how it would look like. The data from the exchange comes to your market data block. So you read the data from the exchange. You store it for future use. You could probably also buy data from third-party vendors. A subset of the data, you could extract it to your operational data warehouse, data store to do your statistical analysis. So the data that you see from the exchange in real time, you would see certain patterns in the data. Now what you would do is you would compare the patterns in the current data with patterns in the historical data. So the historical data that you had, you would extract that into the operational data store. And then you would say that, okay, I see certain patterns in the data. I see that whenever the implied volatility of the at the money options drop by more than X percentage in Y minutes, then it's a time for buying options or selling options. Now, in the real-time data, if you see the similar pattern, you would therefore want to take that action. So the decision is done by the trader in the trader's tool itself. He would analyze the market data for patterns. He would compare that pattern with traditional, with historical data. Now, once the decision to send an order is taken, the decision would be forwarded to the order manager. The order manager would then send the orders to the exchange. So this is how a traditional trading system would look like. Remember, so what you see is a very few connectivities, a very few number of processes. All along you might have noticed that I have trifurcated the diagram into 3 areas using 2 vertical dotted lines. So it's divided into 3 areas using those 2 dotted lines. So what are these 3 areas? The one on the right is the exchange part of it. It's the external world. So it has nothing to do with you. It's external to your system. The one in the center is the server part of it. So what you can notice here is that the server traditionally used to be predominantly a data store. So you get data from the exchange, you store it, you extract a subset of the data for your statistical analysis. This is how a traditional trading system would look like. And obviously the application layer, which is on the trader's machine, this is where you would do all your processing. So traditionally, your server would be just a data store, and all your processing would be done at the trader's machine. So you would need a very robust machine for each and every trader. Sometimes you could have the operational data store in your local trader's PC as well. Well, what has changed with automation? Well, with automation, the first thing that has changed is that orders flow out without human intervention. Because orders flow out without human intervention, therefore the risk management has to be much more robust. It has to be done in real time, and it has to be perfect. Number 2, traditionally, whenever you see an opportunity, you would send out orders manually. So you see an opportunity, you say that, okay, it seems like a good time to buy stock A, so you would fill in the details in your system saying the buy stock A quantity is equal to 100, price is equal to 120. You would double check all the values and then send out an order. So you would not be able to participate in all the opportunities. Now, because with the advent of automated trading, you are letting the computer take that decision. Therefore, it would be able to respond to each and every event in the market. The moment an event occurs, it would just respond to it. So the number of orders that would be generated could be huge. So different exchanges try to restrict the number of orders that you can send to the exchange through each server that you have. So typically these numbers could be something like 400 to 1000 orders per second per server. Which means on a normal day, each of your trading server could be sending close to a few million orders every day. So your order management system should be robust enough to be able to handle such a huge flow of information within the system. At a broad level, all of us know a lot of strategies are very similar at a very broad level. You know that whenever the currency depreciates, the price of an exporter will go up, go down, or you know whenever the price of a particular commodity goes up, companies which use that commodity as a raw material, their share prices will go down and things of that sort. So there are lots of correlations. So when you know that whenever there is a big downtick in the market, volatilities in the market, implied volatilities in the market will go up and things of that sort. But the extent to which you believe that will happen might differ. So I might think that after the result, the implied volatilities will drop by 5%. You might think that it will drop by 3%. Both of us disagree to the extent of the numerically, but then at a fundamental level, both of us believe that it will drop. Now, if fundamentally a lot of these trading strategies are very similar, the fundamental trading strategies, most of them are similar. In that case, all the traders would be responding in a similar way. Now, whoever is the fastest in responding will make a profit, and then the person who is not fast enough will not be able to do the trade correctly. So even though I think 5% is the correct value, you think 3% is the correct value, but because you traded faster than me, you got a better trade than me. You entered the trade faster rather than me, and then even though I thought 5% was correct, but I couldn't actually extract 5% because I was slow enough. So latency reduction has become extremely critical. It has become so critical that people have innovated and built technologies like microwave transmission, the ability to actually code your entire trading strategy in a piece of hardware. So the strategy is entirely coded and implemented in hardware. So there is no software involved at all. So that's the amount of innovation that people are doing just to be able to be faster than others. So what is the first change that people did? So they said that the logic should not be running at the trader's application. It should be running in the server. So instead of the strategy executing in the application, it should be residing in the server. Once the strategy is residing in the server, what you could do is you could actually put your server at the exchange itself. So your entire flow becomes exchange to server, the market data block in the server. From the market data block in server, it goes to CEP in the server. From the CEP in the server, it goes to order manager in the server. From order manager in the server, it goes to the exchange. So everything is within the exchange to server and back. Nothing to do with the application, which is your trader's PC. What are the other changes? Well, people realize, oh no, this is very interesting. How many of you are interested in video gaming and things of that sort? You play those advanced computerized video games. So if you play those advanced computerized video games, you would know that connoisseurs of video games, they typically go for high-end graphics processing units on their computers. Why do they go for high-end graphics processing units on their computers? It's because a computer CPU is designed to do a variety of tasks. It is designed to do input-output, it is designed to do calculations, it is designed to be an all-rounder. In graphics, in computer gaming graphics, you need to render a lot of pixels. So each dot on the screen, it's a pixel. Now the color of the pixel is based on a mathematical equation. Now in computer gaming, to be able to render all these pixels very quickly, you need to do a lot of mathematical calculations. So therefore, there are dedicated graphics processing units which are extremely strong at doing mathematical calculations, which are used for graphics intensive applications. Now the financial industry realized that while graphics processing units were invented for computer gaming, but we could actually use that. So for doing trading is also very mathematical intensive. So what you could do is you could actually do all your mathematical calculations in a graphics processing unit, because your graphics processing unit is designed to do a lot of calculations very fast. So to give an example, yesterday we had a session on options trading. So Black-Scholes is the most common pricing formula for pricing options. On a normal 3 gigahertz CPU on an open source platform like Quantlib, you would take something like 10 microseconds to calculate the price of one option using Black-Scholes. Now, if you use a GPU, you would take 1/10 of that time. But then using GPU is not the solution per se. Otherwise, everyone would have done it. So you have to do it very properly. You have to do it. If you just randomly use a GPU, there will be a lot of communication between your CPU to your GPU and back. So it has to be designed by people who understand the architecture well. So most of us here today, I believe, are traders. So as an end user trader, what you would need to know is that how are the systems changing? Is your system using a GPU to calculate option prices? Is the system using CPU to calculate option prices? What is the comparison between those two? If there are a lot of option prices that you need to calculate on one change in the price of the underlying. So if the option chain is quite long, in that case, a GPU makes sense. So this is one input that a trader can give to the technologist. But if you just want to calculate 2 option prices on every price change in the underlying, then you would not want to use a GPU because you would have to transfer a lot of information just to do 2 calculations. Now, if everything related to calculations and the strategy is done in the server, then what is the application block doing anyway? Well, within the CEP block, you say that whenever particular events happen, execute certain tasks. Now, those events are characterized by certain parameters, right? So you say that whenever the implied volatility drops by 2%, buy at the money option. So 2% is a parameter. So those parameters are handled from the application block. So most of us use the application block, but then what we see is just a user interface to provide parameters. So the to be able to provide proper parameters, you would definitely need to know what is the number of orders you have sent, what is the number of executions that have happened. If you're sending too many orders without executions, then you need to change your strategy. If you're not sending enough orders itself, then you need to change your parameters. What is the position built up? What is the profitability of the strategy? Based on those, you would be changing the parameters. Now, what is one of the most critical blocks within the application is actually the within application RMS. What is RMS? RMS is risk management system. So within application RMS would ensure that you don't mistakenly enter a wrong input into your system. So instead of saying that I want to buy at the money options at a volatility of 20%, you should not be allowed to enter 200%. An extra 0 would mean that you would buy everything in the market. So your within application risk management system should ensure that you do not do those fat finger kind of errors. Everyone here knows what a fat finger error is, right? So if you have a very fat finger, you would end up pressing a wrong key. The most critical RMS, however, happens in the OMS. So once your strategy does all the processing and then it says that, okay, a certain order has to go out of the system, it says that it's a good time to buy or sell. It says that the current event is similar to an event that I've seen in the market. It says that it's a time to buy. So after the order is generated, the OMS does some risk management checks. It says what is the total value of orders that has gone out to the market already. What is our net position so far? So it will say that since morning I have already sent out buy orders worth 1 million baht or 2 million baht or 100 million baht or whatever. So it will say that I'm not going to send any more buy orders because I've reached this RMS check. It will say that I'm not going to send an order which is 2% or 3% away from the last traded price for that instrument. There could be a whole host of risk management checks, so we are going to touch upon those a little later in this evening. Well, because everything is automated, you need an ability to actually monitor what's happening. So I mentioned the RMS within the order manager. It actually listens to it actually checks each and every order before sending it out to the exchange. So it says that the total value traded so far since morning is 100 million baht, so I'm not going to send this order. But what is the total value of orders that has been sent to the exchange so far? So all those numbers, the status of the system, you need to be able to monitor from somewhere. What is the number of orders sent? What is the buy position built up? What is the total vega of all the portfolios, total delta of all the portfolios, and so on. So that is what you. So there has to be a block which can actually show you the status of the system. What is the number of orders that you are sending per second, and so on. Now, traditionally, a lot of exchanges designed their technology systems independently. So the exchange said that, okay, I'm going to send out information about my market prices in a particular way, and the second exchange would say that, okay, I'm going to send information in my way, and so on. So each exchange would have their own methodology of sending out information about prices in the market. But very quickly, people realized that every time a trading member, every time a participant wanted to connect to the exchange, he had to build his technology system to be able to understand the technology of the exchange. So the exchange sends out information in a particular format. Now you need to build your system to be able to understand that format. So what a lot of exchanges did is, they said that, okay, we are going to adopt a standard. So all of us are going to send orders information in a very standardized format. So one of the most common, there is something wrong, this just keeps so a lot of exchanges, what they did is they said that, okay, we are going to adopt a standard. So the most common standard right now is the fixed standard, so the fixed protocol, financial information exchange protocol. So what it does is it ensures that all the information, all the exchanges send out information in a very similar format. So I'm going to actually show what the fixed protocol looks like a little later in the presentation. So we'll touch upon those. Well, different exchanges would send information in different ways. You would need a way to denormalize that information and to convert it back to a format which is uniform for the system. So different exchanges would send information in different ways. Your data denormalizer will convert that into a standardized format. Well, with automation, now it is possible for traders to monitor multiple markets. You say that I know how the commodity market affects the equity market. I know how the Chinese market affects our market, for example, probably. So I know how the Australian market affects my market. So what you would do is you would connect your trading server to multiple exchanges. You would say that I know these are interlinked, these are connected. Earlier, when there wasn't automation, it was difficult for a trader to manually trade in multiple markets, manually manage his positions, and manually manage his risks across multiple exchanges. Now with automation, you just have to write down a set of rules in your computer program, and then it will trade in multiple exchanges, it will manage positions, it will manage risks in multiple exchanges. So therefore, you have your OMSs are now connected to multiple exchanges, and therefore, and you need an order router to actually route the orders to the correct exchange. That is another component within the OMS. The regulatory requirements have increased drastically. So therefore, in India and then from April 2014 in Germany as well, you are expected to keep a record of each and every strategy parameter that you had sent out to the exchange, which is a lot of information to write actually. And then the process of writing all this information to your records incurs so much. It's such a time-consuming process that your strategies sometimes become unprofitable. So there was this high-frequency trading firm in Cologne, Germany, they stopped trading after the new regulations because they keeping on writing information to your hard disk after every order slowed down their system so much that they stopped trading. Well, there is one interesting facet that I would like to mention here. I mentioned how trading strategies could now use information from multiple sources because instead of a human being looking at prices, it's a computer reading the information, reading numbers. So it could use information from multiple places. It could say that, okay, 7 Southeast Asian markets, all of them are down 3%, so should I be selling TPEX or not? So this is a very basic example, but it could also use sophisticated information. There is a science called as quantified news analytics. So what it does is, what is the most primary thing which affects the prices of stocks? The most primary thing that affects the prices of stocks is the news on the stock itself. Now, the amount of time that it takes for a human being to read a news article and respond to it is quite huge. So what people do is they use sophisticated text analyzing software, and this text analyzing software reads the entire news article, and then it says that this news article is about a company called X, and then it expresses a negative sentiment about the company, and then it's a very relevant news article, so it's a time to sell stocks on company X. So such a software would scan through the entire article and trade in less than a millisecond, and a human being would not even have read the headline of the news article. So connecting quantified news feeds, so you're connecting your system to news sources. So it's not just exchanges which are connected to your trading server. You also connect news sources to your trading server, and then you run quantified news softwares which quantify the news. So it's a piece of text. You convert it into quantified numbers, and then you trade on the basis of that. It's a very interesting domain, and there are quite a few firms which are working on it globally around. In fact, there are a few hedge funds which trade only on the basis of quantified news, nothing else. The two main providers of quantified news software, Dow Jones, Ravenpack, and Thomson Reuters, and now Bloomberg is also coming into the sphere. Each of them have 100+ customers. So that is the number of people who are actually using quantified news in their trading strategies. So that's one of the additional inputs to your trading system. It need not be an exchange, it could be a news source as well. Now, while Nitesh was mentioning the benefits of algorithmic trading, one of the biggest benefit is that the trader who traditionally used to be someone who used to just monitor the market. So he would sit in his desk, and then he would keep monitoring the market, and he would just wait for a particular event to happen. He will sit on his desk, and then he'll say that, okay, has a particular event happened or not? So he will just keep monitoring the market for that. And the moment the event happens, he will just punch in that order and then send the order to the exchange. And while punching it, he will double check, triple check, cross verify quite a few times. Now, so traditionally, a trader's role was very operational. You would wait, just scan the market data throughout the day, waiting for events, number one. Number two, the moment the event happens, you would just type in the order details, check it twice and thrice, and send it out. What has happened after automated trading? The trader does not need to monitor the markets. The computer monitors the markets. The trader does not need to punch in the order details. The computer generates the orders and sends it out to the exchange. So the role of the trader has shifted. It has become more of an analytical role. Traditionally, traders were burdened with so much of monitoring the markets. so much of operationalizing in terms of feeding in the order details. Now with automated trading, the trader can actually analyze, and because he can gets time to analyze, he can use information from multiple sources, and now he has the time to because he has so much information at his disposal. People are now asking for advanced analytics, statistical analytical tools, which they can link with their trading system. So today, if little later in the day, we would be showcasing the flex trade system. So within flex trade, you actually have the ability to link R to your system. So R is the most popular statistical analytical tool globally. So the ability to actually interface your trading system to a statistical analytical tool, that's very critical. Okay, so I'll just very quickly use this chart here. So, what is the typical flow of an strategy development? The typical flow is someone who has an expertise in the market would create an hypothesis. This is. Once you formulate the hypothesis, what do you do next? You validate your hypothesis by doing a lot of statistical tests. So you extract a lot of historical data and then you say that statistically, is the hypothesis true? So you do your back test statistically. Again, using historical data. What is the third thing that you do? If the hypothesis turns out to be true, you say that, okay, the hypothesis was true, so let me implement that on an automated trading system. So you implement on automated trading system. What do you do next after this? After you have implemented it on an automated trading system? Well, you don't just trade it on the exchange straight away, because say you are the person who made the hypothesis and then you are the person who implemented it on the platform. So you are a technology expert. Say you are a technology expert and say you are a finance expert, a market expert, and you've made the hypothesis. Now it's possible that the person who made the hypothesis had a particular view, but then because of communication mismatch, the implementation in technology was totally different. So instead of buying on a particular signal, the technology implementation ended up selling on a particular signal. So you need to test whether validate implementation. Now validating the implementation is both from a technology perspective, whether it was implemented correctly, and number two, whether the system can actually handle the complexity involved in the market. So the software programmer might have designed the system and then tested it for a few particular scenarios, but then when you actually trade it in the market, you might have to trade it on days when the market was very volatile, so which would involve a lot of data flowing into the system, a lot of calculations, a lot of orders going out of the system. So is the system able to handle such complexity? So validating the implementation. So how do you validate the implementation? Obviously you don't send orders to the exchange to validate your implementation. The way you do this is by sending orders to a simulator. So simulators are software programs which pretend to be like the exchange. So you send orders to the simulator pretends to be like the exchange. So it says that these are the prices in the exchange right now. So based on these prices in the exchange, you would have gotten a buy trade, or your order would have been executed at a particular price. So it would give you a fill at that price. So you send out orders not to the exchange but to the simulator, and your simulator simulates the behavior of the real market, and then therefore you get to see how your strategy would have performed for different types of scenarios. So what you could do is, so and then go live. So validation involves working with the simulator. Now, if you could only test your system during market hours by using live market data, that would be a huge hindrance to development of the system. So what you could do is, you could a lot of the systems give you the ability to actually replay historically stored data. So you said that I want to see how the system would have performed on a very volatile day. So you would replay data from a day when the market was very volatile. So you replay the data, you send it to the system, and your system will then send orders to a simulator instead of sending to the real market. So you get to see whether the technological implementation is correct. You get to see whether it can handle the complexity. You get to see how the strategy would functionally perform for different scenarios, on a day when the market is volatile, on a day when the market goes up, on a day when the market goes down. So in fact, there are a few more blocks, and then there are a few more interlinkages which I have not put here, because this is a very broad generic diagram of an automated trading system. So, but if you remember the initial diagram of architecture of a traditional trading system, you would realize that the architecture has become way more complicated. The number of blocks has become huge. Remember, in the traditional system, there were just 5 blocks. Now, it will take some time for us to count the number of blocks. The number of connectivities, it's just too humongous. It will probably take us 2 minutes just to count the number of arrows going from one place to another. So that's the amount of complexity in the system. What does it mean? It means that to run this profitably and successfully, you have to ensure that all the processes are running at all points of time. You need to ensure that all these linkages are right. So even though both these processes might be up, but this linkage software link could be down. In which case, and if you actually understand the architecture of your system, you could detect where a problem in your system is probably occurring. If you see that the pricing of your options is off, is not in line with what the prices in the market are, then as a trader, if you understand the architecture, you could very well point out that, oh, probably this connectivity is down, or something of that sort. So that's why it is critical to be for a trader to at least understand at a broad level what is the architecture of the system like. Where do the option prices come from? So if that process is down, how will it affect my system? Well, fixed protocol, as I mentioned, it's a set of tag and value of that tag here. So these are standardized tags. So if you want to send a new order to the exchange, so what you do is you say that I'm sending an order. So you set 38 is equal to 10, which means I'm sending an order of size 10. 40 is equal to limit. So it says that it's an order of type limit order. The price is equal to 100. So 44 is equal to 100. So here, if we had 44 is equal to 100, it would have meant that we are sending an order of size price at a price of 100, and so on. So this is how fixed protocol looks like. What the now say you have a trading system which has gone wrong. Despite all those risks, checks and balances, somehow it has gone wrong. So what do you do in that case? What do you do if things have gone wrong? So the exchanges, to protect something of that sort, what it has done is it has implemented certain throttles. It says that you cannot send out more than X orders per second. So that is it. So I'll very quickly go through some of the technology innovations. What's happening in the world of automated trading? What are the kind of innovations people are doing? So So basically, traditionally, fiber optic cables were laid along cities. So this is the diagram of fiber optic cables between Chicago to New York. Traditionally, they were laid along cities. So what happened? The cables were not the straightest path between Chicago to New York. The cables took a very long circuitous path. So traders, they realized that if they could actually have a straighter connectivity between New York to Chicago, they could trade much better. So there was one firm which installed a fiber optic cable which was slightly more straighter than the existing fiber optic cables. So originally it used to take probably around 18 microseconds through the original linkages. So people invested in new fiber optic cables which could actually connect them between Chicago to New York at 13 milliseconds. After that huge amount of investment, a new set of groups, new set of hardware guys came up, and then they built a newer link which could connect Chicago to New York at 12 milliseconds. Now people are devising microwave communication between 2 points, so you could actually communicate between New York to Chicago at 7 to 8 milliseconds. So that's the amount of investment that people, and each of these laying a fiber optic cable between New York to Chicago, which takes 12 milliseconds, actually required them to dig through hills and mountains and then under rivers and so on. So it was a hugely expensive affair. That's the amount of interest, that's the amount of investment that people are doing just to be able to send orders faster. That's a huge amount of investment that people are doing. What is this diagram? This diagram is actually of an FPGA. What is an FPGA? You actually program your strategy in the hardware itself. Now the amount of investment that people are doing to be able to write your strategy in hardware is immense. So hundreds of millions of dollars spent every year to be able to write your code in hardware rather than software. So this is the kind of competition that you might be gearing up to. So typical numbers involved with latency numbers. So if you're connected to the exchange, in most cases within 1 millisecond you would get your response from the exchange to your system. But within your system, what are the latencies involved? Within your system, the exchange will send information to you. It will come to your routers, it will come to your switch. This is the amount of time, 100 to 300 microsecond is taken up there. That will send it to your network interface card, from which it will go to the operating system and so on. So a lot of people have actually put in a lot of hardware programming at this layer itself, so that the strategy doesn't have to go all the way up. A lot of people, what they have done is they have modified their operating system, the computer or operating system, so that the kernel itself is bypassed, the operating system itself is bypassed. So the switch can the NIC can directly put the values here. So basically a lot of people have retuned the operating system. So the way the transfer of information happens within the operating system, so TCP, that has been modified. People are moving the software as close to hardware. Instead of using reusable code, you write code which is specific to a task. So traditionally what people would do is they would build a block of code for a particular task and then use that in different for different purposes. Now in automated trading, the shift is towards writing the entire piece of code afresh for every strategy. instead of using reusable code, because when you use reusable code, there is a lot of inefficiencies. You could actually isolate your CPUs and then say that, okay, this my server has say 32 CPUs or 64 CPUs. So out of those 32 CPUs, CPU number 1, 2, 3, 4, 5 would be used for market data or for CEP and so on. So you actually dedicate CPUs, log free codes, and so on. Within hardware, what do? You actually write your strategy within the hardware itself. The amount of disk writes is also a very hugely time-consuming exercise. So every time you write information to your hard disk, remember in normal hard disk, the moment you do a lot of disk writes, you hear a sound. That's because the disk is rotating. There is a pen which is writing to the disk. Now, if your disk has to keep rotating for information to be written to the disk, that's a lot of time that is consumed. So there are solid state drives where the drives don't move around. So this is the story that I had already mentioned. The good thing is we are approaching the limits of physics. So while people are investing a lot of money on technology, the cost of technology is reducing, number one. And number two, we are approaching the limits of physics, which means that very soon everyone will be able to afford the same technology. And that technology would be very close to being the best. So once again, the advantage would be in quant models and not in technology. Because everyone would have the best technology because the cost is coming down drastically. Okay. The example is not
Hello? Alright, so let's very quickly go through the some of the risk management parts. We'll not cover all of it, but just a bit of it, just for your understanding. So first part that we had created was more for the fun part. So just to know what happens, what has happened in the recent history. So like this one is a case from November 2007 involving Credit Suisse. And what had happened was the trader who had implemented the code change parameters. So typically what you do is that you have a spin box like this over here. So if you want to put in a order quantity or something, you just press up, down, whatever, something like this, right? So so if you increase, it will go up. So if you increase to 10, so it will go, then you click OK, then it goes like, all right, so the quantity has changed to 10. But this guy, what he did was, the confirmation was not required, okay? So what happened was that when a trader accidentally pressed it for too long, so the quantity went berserk without any confirmation. So obviously the result was over here, hundreds of thousands of cancel orders sent to the exchange, order logged in as NYSE. As a result, $150,000 fine. Then let's go for the more interesting ones. All right, so in this one, what they had done was Deutsche Bank in more recently, June 2010, they sent like 10 times the normal volume they created. They sent 1.24 million orders for the Nikkei mini futures. The exchange system completely clogged. The market dropped 1% just because of those orders. This was more interesting fine. They were just asked to just shut down the shop. Then you have the Knight Capital, which is a more prominent one in the recent times. So like Deutsche and Credit Suisse, they were not so much in the news, but the Knight Capital, this was probably the most humongous incident which happened related to algorithmic trading. The reason was simple, that there was some change, there was some feature which was introduced in 2004, 2005 in the system, all right? And that change was like that feature was not being used anymore. So when the but they didn't remove it for some reason, and maybe probably they missed it. But 10 years down the line, almost 8 years, 9 years down the line, another feature was introduced in a strategy, and it happened to interfere with that feature. The result was that within a matter of about 40 minutes, I guess, or 45 minutes, it sent out orders at crazy prices. And it was a reasonably big group, Knight Capital, and the loss was $460 million in 45 minutes, and it went bankrupt and was taken over by Getco, and now Getco is called, they did a reverse merger, and now it's called the KCG Group. So the Getco it's after being rescued by Getco. Goldman Sachs. So this was again. There are certain indication of interest which you give to the exchange when you do not intend to buy or sell, but you are just expressing an interest. So some bug happened in which instead of sending an expression of interest, it sent the orders itself. Okay, so that meant a trading loss of $100 million. But, or rather, I think it was a fine, I guess. No, it was a loss. Sorry. But the interesting part is that Goldman Sachs Algorithmic Trading Division and the Derivatives Division, it made about $100 million on every day in the second quarter of 2009, all right, except for 1 or 2 days. So this is not much for them, but yeah, obviously, if you do not do it correctly, then that can be very crazy. Then I think this is closer to home. I was right, happened in China, but yeah, it was more of a fat finger mistake which happened. Then you have, this one is also not that interesting. Flash crash, I think this is something similar to the airlines, something similar to flash crash. So like Rajib said about news analytics. So there was some story which Google News bots picked up wrongly from 2002 regarding United Airlines possibly filing for bankruptcy in the event of something which has happened. So, but the problem is that it was a 2002 news which came into implementation in 2008, right? So obviously it was a massive crash which happened because of this. This one is more interesting one. This is even more recent, April 23, 2013. Market drops 0.8% for a second or maybe a minute. The reason, a Twitter account of the news publisher, I think ANI, but sorry, which one? AFP, yeah. So AFP's Twitter account got hacked, and someone posted false news of White House explosion. And as a result, there are a lot of news analytics and the other systems which picked on this, and they sold it like anything. So obviously, all these things are quite tricky. So when you're using tools, you have to be very careful. So obviously, it can help you make $100 million on every day for the whole quarters, but yeah, it can lead to massive losses and closure of business as well if not done in a proper manner. So very quickly going through some of the algorithmic trading risks which are there. I think so. This is like access related risks. So your connectivity to an exchange goes down, the exchange disconnects you, someone digs down on your network cable or something on the road underground. So all those things can happen which can lead to massive losses if not handled correctly. Consistency, like biggest one is market data is stale, in which the connectivity is lost, but your strategy is still firing orders using the stale market data. Algorithmic, these are all the risk management checks that Rajib had earlier mentioned, that regarding your how much to buy, how much to sell, there are limits which has to be set. So which he showed in the architecture diagram. So that's there. And technology, these are more critical ones and more difficult ones to handle. So like your hard disk got full, or a virus attack happened on your server, or some system crash or protocol mismatch. So all these things They are most likely more difficult to handle, but they can be handled. So like for hard disk gets full, you can have notifications which keeps coming, the emails that keeps coming, that if it is full, if it is 60% full, send a notification. If it is 80% full, send a notification. Similarly, even if for the network clashes, you can have the, for the socket level, you can check that how much is it, if the network is broken or something like that. So these things can be done. And scalability, it's again, you can do it using the, there's more, not as much of a risk, but more of the business opportunity loss if you cannot do it correctly. So ultimately, knowledge is the key. If you know it, if you can implement it correctly, it can do wonders for you. If not, then it can be really messy. So that's ways. Oh, okay. And this is about obviously about the knowledge. So this is Gautam Buddha logo of ours. So which is about executive program and algorithmic trading. What we cover is like statistics and econometrics. That is for the strategy building, financial company technology, the things that we went through. So similar things in much more details, obviously. And this is on algorithmic and quantitative trading. So this is about the strategy part. So all the different strategies. So this is more details like basic stats, advanced stats, time series analysis that you have. In the financial computing, you have programming, C++ or R, as he was saying about the analytical softwares, statistical tools like that's again R, Excel, and system architecture. And regarding the algorithm quantitative trading, this is a more detailed part in which you have various paradigms of strategies, be it market making or be it pairs trading, statistical arbitrage or options or delta, all those different paradigms, artificial intelligence based strategies. So all those are covered over in this domain. So yeah. So and then you have project which encompasses all of it. So that's there, and that's about it from our side. So yeah, so I think we'll just show you a brief demo as well, which we wanted to show you, but I think with the paucity of time,
So basically we wanted to dispel the myth that automated trading is complicated. So just before you guys started, so probably we started at 6:30. At around 6 o'clock, remember that I'm not a programmer. I'm actually a quant guy, and then I started programming this on FlexTrade, and then we actually have a pair trading strategy almost ready on FlexTrade already. So the system is just so very simply flexible that you don't need time to code a pair trading strategy. So this is how the platform looks like. So remember an automated trading system, you see the market data number one, you see
this market data is all replay market data. This is not obviously the market is not on right now, but just the replaying, that the market data that we are replaying for some previously recorded session.
And then you get to see your orders here, the trades that have happened, and then you get to see what is the position that you have built up here. So it would say that what is the average price at which I have sold, the average price at which I have bought. And then when you send orders from it, you can send orders to a simulator. So the simulator is a similar tool wherein you could actually see the list of orders, and then you could actually give fields saying that, okay, trader KV1 sent an order to the simulator, give a field to it. Or you could write a rule which could automatically give fields. Then you also have a third user called global user, wherein you could actually see the state of the system. It would say that this is the total number of orders gone out to the exchange, this is the total buy value, sell value, this is the total risk of the trader. It was you could club traders and then say that for the group of traders, trader 1, trader 2, trader 3, this is the entire risk. For group traders 4, 5, 6, this is the entire risk, and so on.
This is just the application. So basically, this is the application part, and but the view that you're having, this is also running on a server. So this is not like it's running on this laptop. So this is remotely connecting to some server, and you just program different strategies, all those things over here. I think he might have created some strategy, maybe, I don't know. This one. So this is the one that he was creating. So a simple strategy which it checks the value of one and sends order to the other strategy. A simple pair trading strategy which probably a non-programmer like him could do in 10 minutes. So, so yeah.
So basically, what a pair trading strategy involves, all you need to do is you say that buy B at X into price of A plus Y, for example, say, and sell B at this price. So all you need to do is you need to get the values of A, you need to get the values of X, Y, and Z, Y dash. So Y I have called demo P1, demo P2, demo P3 in the user interface. And you get those values, you calculate your values, then you check what is your existing position. If the existing position allows you to trade, you send an order. That's it. Your pair trading strategy is just this much, this many lines. And well, you say that, okay, this is a pair trading strategy, but then what do I do next? Well, you can very easily convert this into an option volatility trading strategy. You could say that instead of getting the values of market bid for the instruments, you could just get the bid implied volatility. I get the bid implied volatility, I get the ask implied volatility, I sum those up, so you get, and then average it out, so it's the implied volatility, average implied volatility for that option. And you instead of saying that buy B and sell A, you buy B and A both, so it becomes an straddle buying strategy, two-leg option strategy. So writing a two-leg option strategy is actually the simpler part. The backbone is just less than 40 lines of critical code. You want to have a three-leg option strategy, a butterfly trading strategy. You say that you want to buy a butterfly at a price whenever the price is less than X. It's not going to be more than 50 lines here. But then obviously you would want to ensure that all the boundary conditions are handled. And those, writing the backbone is always easy. Writing the first 90% takes 10% of the time. Writing the last 10% always takes 90% of the time. Those edge case boundaries.
All right, so yeah, I think that was just to give you a brief demonstration about that. So now if there are any questions, we'll be glad to handle. Should I close it? Anything? No questions already? I think it's 10. We are 10 minutes behind schedule, but yeah, I think it's all right. So, if there are no questions in that case, I thank you all. Thank you very much for coming over here. It was lovely sharing all these things and all these stories with you guys. Hope it does help you, and we hope to see a lot of you into the algorithmic trading industry in coming years. So, all right, thank you very much. Thanks all.